It's possible that James Webb discovered the enigmatic population 3 stars. A recent discovery appears to be interesting, produced by astronomers using data from the James Webb Space Telescope. They have discovered light from ionized helium in a far-off galaxy, which may be proof of the enigmatic population 3 stars. Although these stars have never been seen before, scientists are very certain they exist or once did. Primordial gas, mostly hydrogen and helium, which filled the cosmos immediately following the Big Bang, makes up population 3 stars. These are believed to have been the first stars to form. These were large stars that would have gone supernova after a brief existence, causing its elements to be dispersed throughout the universe and giving birth to other stars. An interesting finding by astronomers is the detection of light from ionized helium, which may be proof of population 3 stars. It might help us comprehend how the first stars formed and how the cosmos has changed since then. Learn exactly what James Webb discovered in this video and why it is crucial to our knowledge of the cosmos by following along. The designation due to the Second World War, Los Angeles began to experience several blackouts in 1942. For the majority of people, it was a dark time. Strangely enough, though some of them were able to seize the chance presented by the challenge. In order to resolve the Andromeda Galaxy's nucleus and 2 of its elliptical neighbors, German astronomer Walter Baade, who immigrated to the U.S., strained the Mount Wilson 100-inch telescope to its absolute limits throughout the years 1943 and 1944. He profited from the blackout. What he found was that he called the 2 star populations that Andromeda was home to population 1 and population 2. Baade observed no extremely bright blue or red stars. Instead, he found what he dubbed population 2 stars, which were dazzling yellow giants. These stars were different from the population 1, or typical stars in our galaxy's vicinity of the Sun. Baade outshone his more well-known colleague Edwin Hubble, who was like a one direction of cosmology, revealing that galaxies exist and the universe is expanding, making cosmology now a more popular science, thanks to the astounding finding of a second stellar population. Astronomers have been using this useful classification since Bade's great discovery was published. We currently know a great deal about the 2 populations. These stellar populations' constituents vary from one another in a number of ways, most notably in age, chemical makeup, and location within galactic systems. What are population 1 stars? The stars, clusters, and associations that are younger and are thought to have originated between 1 million and 1 billion years ago make up population 1. These stars are classified as extreme population 1 objects and are frequently hot blue-white O and B-type stars. They are located close to the arms of irregular galaxies like the Magellanic Clouds and other spiral galaxies, as well as the Milky Way and other galaxies. Such stars are assumed to have formed from a mixture of interstellar gas and materials produced by amazing supernova explosions. As a result, the substance became richer in elements like iron, nickel, and even carbon. Similar to how the Sun is made, about 90% of population 1 is made of hydrogen, with the remaining 10% being helium. What are population 2 stars? On the other hand, population 2 stars, which are primarily composed of hydrogen and helium gas, are typically found in the halos or globular clusters of galaxies. They are generally less common and dimmer, and they are much older than population 1 stars. These stars often have lower metallicities and less heavy elements as a result. Generally speaking, the metallicity of a star can be determined from its spectral lines. At the same temperature, metal-rich stars will typically exhibit more lines than metal-poor ones. Thus, a metal-rich star spectrum is much disorganized. Population 2 stars have low surface gravities and generally flat spectra because they are often metal poor. The reason they only display strong hydrogen lines is because they have an abundance of it. Since they have been mostly untouched by outside causes for billions of years, they tend to be redder in color than population 1 stars and can also be used as a tracer to determine the age of the universe. What are population 3 stars? Later, the classification created by Bato was expanded. Here is where our enigmatic population 3 stars come into the picture. When it comes to astronomy, population 3 stars are the cool kids because no one is entirely sure if they exist, but if they do, they may have some incredible ramifications. These stars might theoretically be split into 2 categories. The first is the first to produce metals and is composed of primordial gas left over from the Great Bang. The second is speculative, but it might be the galaxy halo's dark matter. These stars may have originated in the early stages of galaxy formation or even in pregalactic eras. Nonetheless, the population 3 stars might be a fascinating and enigmatical aspect of the cosmos. Considerably more needs to be learned, don't you think? Population 3 stars are extremely old stars. They are the cosmic great-grandparents, or, as astronomers would say, the forebears of every star we are aware of. These stars, if they exist, must possess some intriguing characteristics as they originated immediately following the Great Bang from the available primordial gas. They are anticipated to be made entirely of primordial gas, specifically hydrogen and helium. That's it. Lithium and beryllium might be present, but otherwise nothing. With the exception of the hydrogen and helium lines, the spectrum of a population 3 star, if we could discover one, would be essentially flat. In actuality, the primordial gas was fresh from the Big Bang and had not yet been recycled from earlier star generations. The population 3 stars don't contain any metals. The majority of these stars, according to astronomers, exploded into supernovae, which eventually dispersed the metals produced by the nuclear burning processes that took place during the lifetime of these massive stars and helped give rise to the population 2 stars. Do population 3 stars even exist? Even though we have a solid theoretical foundation that looks to suit everything and explain what we see today, the main issue with population 3 stars is that we have never seen one. Astronomers have analyzed millions of stars, but they have never been able to locate one with a totally flat spectrum. Some of them were actually duped into believing they had discovered one only to learn that their star had actually indicated the presence of metals. So, they had to take it out of the running. The problem is that it is exceedingly difficult to discover a star with a nearly flat spectrum, especially when all measurements are influenced by instrumental imperfections, which further complicates matters. Yet astronomers are aware of where to search. In fact, if the theory is accurate, we anticipate that population 3 stars will have 2 distinct, elongated emission lines that result from ionized helium. Basically, we might be facing a population 3 star, one of the first stars in the cosmos, if we ever succeeded to identify several stars with a really flat spectrum and 2 strong emission lines of ionized helium. Regrettably, no one has found anything up until now. If I were an astronomer, I would question if it is still worthwhile to attempt. But thankfully, James Webb is here. We are getting closer to the answer to this puzzle with the help of this wonderful telescope, this incredible work of art. James Webb finding. We are all aware of how valuable a scientific treasure the James Webb Space Telescope's photos are. A report evaluating almost 2,000 different targets seen in JWST pictures and searching for particular helium emissions was released in December 2022. They anticipate to discover the same helium emissions in population 3 stars. They learned from their study that the universe was still a newborn 620 million years after the Big Bang when a galaxy with a redshift of 8.16 first arose. It was interesting to note that the galaxy appeared to be divided into 2 halves, with the helium signature and many other elemental signatures present in the first half. The intensity of the helium emissions suggested that this might be a zone rich in population 3 stars, contrary to the initial assumption that the population 3 stars in the galaxy had already produced many younger stars and other emissions. This is a particularly exciting discovery because it was also discovered that the emissions lack traces of oxygen, nitrogen, or carbon, which rules out the existence of a black hole. James Webb may have discovered an area of the universe that is abundant in population 3 stars. There are many different explanations for the source of the radiation from the galaxy, thanks to the research published in December 2022. It will be fascinating to see what new research reveals and to find out more about this unusual discovery. Sadly, because what we see is a conglomeration of several emission lines, this discovery doesn't really tell us anything about the existence of population 3 stars. There is no method to separate the components to test the possibility that this galaxy is made up of population 3 stars and other kinds of objects. The light of population 3 stars that has been magnified by the phenomenon known as gravitational lensing is what astronomers are looking for. This relativistic phenomenon takes into account the fact that light is bent when it approaches a large object. For instance, a big cluster of galaxies between us and a population 3 star may cause the light from the star to be bent and, as a result, magnified, just like it does with a lens. Several stars have already been found using this technique, but it is a fairly uncommon occurrence due to the geometry of the issue. You would need the lens, for example, a cluster, to be aligned with the emitter, in our case, the population 3 star, and you also need to be fortunate enough to be observing that particular region of the sky at the time this happens. So what can we conclude? Population 3 stars seem likely to stay elusive in the future based on the available evidence. Although it can't be fully ruled out, the likelihood of discovering some population 3 stars in the far reaches of the universe is still extremely low. We will need to keep making observations and doing research to improve our knowledge of how these strange stars form and evolve and to learn more about the early cosmos. Hopefully, James Webb will also undoubtedly assist us.